In this video, we're going to talk about the Linux environment, and we'll also talk about searching with the find command. However, before we start, I want to make sure that we cover links. If I look at my file directory right now, you can see I have some different files. I'll do an ls-l so we can compare. And suppose I want to create a link here to the C directory from the code examples. I can do ln-s for a soft link, and then I give it the directory, and then I give it the link a name. So now if I do ls-l, you can see that I have a link, C files, that links to that directory. And if I wanted to link to the README there, I could create a link called readme.txt, and you'll see now I have readme.txt and C files. So if I VI that file, or that link, you can see that there's the README file for that particular directory. And if I cd to C files, notice now it shows that I'm in this directory, but if I do an ls, I can see all the example code that's there. So that's a quick example of using links. Our next topic that we want to talk about is the Linux environment. This is a pretty lengthy topic, and so we're going to really just try to focus on the general ideas. In your shell, when you load this up, there are a lot of environment variables and shell variables that get set. So the shell variables you can set in your bashrc file. So if I do an ls on my home directory, we'll do bash star, and you can see there's several files here. You have a bashrc and you have a bash profile, and that's where you can do things on startup, including, for example, here we're setting the path variable, and bash profile, actually the first thing it does is actually load the bashrc file, and then you can add additional environment variables, programs to run on startup, and assign values to different environment and shell variables inside that file. So that's where that comes from. If I do the printenv command, I get a whole bunch of different things that are displayed. So first off, you can see this ls colors environment variable, which does something, I don't know what. But then there's a lot of different other ones. So here you can see, here's my username, and my desktop session is a GNOME desktop session. My current working directory is an environment variable. And you can see there's a bunch of other stuff here that sort of give information about my system. So one of the ones that we saw was the print working directory. But if I say cd to /bin and make that call again, notice that environment variable changes as I go to different locations. So I'm going to go back to the module 4 directory. So in some systems, there's an editor environment variable. Here, there's not. But I could set that up. To say that I want Vim to be my default editor. And so now any program could actually read this environment variable. In fact, later in the semester, we might write a C program that does just that, where you can allow the program to be modified what it does based on the current environment that you have set. There's also the path, and we can update the path by saying path is equal to, and we want to include the existing path, and then let's add, actually, why don't we just add the directory we're currently in to our path. And remember how normally you have to write /a.out? Actually, for us, we can just write a.out now because we added this directory to our path. Again, you don't want to necessarily add the current working directory to your path, but sometimes there might be specific directories that you want to be able to get to. So there's also a environment variable that demonstrates what the shell is going to be. So you can see that this gives me the username at the host name, a space, and then this indicates the current working directory. I could also make the shell or the prompt just say hello. And so now that's my prompt. And some people like the directory to be included, the full directory. So I could also set ps1 to pwd and then /u/h w, and then the $. It didn't like that. Because I need an @ here. And it still didn't find that. Okay, so let's see if we can set it back to what it was before. So here's what's happening is it's actually, if I echo what I was trying to set this as, notice it still doesn't like that. So it's seeing this colon as two separate things. So let's surround this with single quotes. So that'll be better. And now I can set ps1 equal to that. Might need to do this in back ticks. There we go. So now, and I don't need that semicolon, it looks like. So now, yeah, sorry, that was a long road to get here, but notice here's my working directory, and then here's my information. Now I don't really like it to be that. I like what it was before. So I'll delete all that. And now I'm back to what that prompt was. And you can even put like if, there's lots of stuff you can do with that. That's sort of a toy thing though. It doesn't really make a lot of difference. Also keep in mind that the tilde is your home directory, so you can always use your tilde in place of that. And then finally, keep in mind, if you want to modify things, if you edit bashrc or bash profile, you can have these come up as you log in automatically. So here you see we're setting the path. Once you set it, you export it so that it's available to every subprocess. But again, there's a lot of things that you can do there. And we don't have time to go over all of it in this video, but there's some good examples I think that give you a good start in thinking about what you need to do. So there's more in the notes in this if you want to know more about these environment variables. So we've talked about the find command before, and this is something that's going to be very helpful. So I'm actually going to go to my root directory here, and there's a lot of different ways I can look for a file. So for example, I can look for a file, find the first argument is going to be the path where you want to look. So that it's going to look everywhere under that directory. So this says look under this directory and find files with the name hello.c. And you can see there's several different ones. I could also find all C files that start with the letter S, like this, and it'll do wildcard substitution. And let's suppose I was really only interested in ones that I did in Devel CSC Summer 19. So you can see there's the files that start, C files that start with S. I can find files that are 1 day old using the -mtime1. There they all are. I can also find ones that are less than 1 day old, put a -1, or more than 1 day old, +1. I can look for files that have a specific permission. So there you see a bunch of files that have 775 permissions. I can go to my development directory and I can find in that, or actually let's look in the code examples directory, where the type is a file and the name is not something that ends in C. So there's all the prologue and scheme and README files that are in that directory. Or let's suppose I'm interested in scheme or prologue and I want to find all scheme or prologue files in that directory. I can do / and then parentheses, I say name, and then or. Actually, I thought we were doing scheme files. And you'll notice I'm escaping the parentheses. The parentheses are there just to say I want this condition to hold. And so there's all the scheme and prologue files that are in that folder. Let's say I want to find all the directories. Oops, don't forget the name or the location. So there's all the directories in the subdirectory. How about where the name is not Git? So there you go. Now, this isn't the name here, you'll notice. So that's why it didn't find those. So there are a lot of other examples with find. Later in the semester, we may even get into where we try to execute programs based on find. But for now, I think that's sufficient for what we want to cover.